Good evening. Today's session we're going to discuss about the 8085 assembly language program, which we call it as ALP. Using mnemonics or instructions, we're going to write a program. The first program is to add two 8-bit numbers using 8085 microprocessor. So let me take two numbers, and the sum of two numbers is going to give a carry. First, let me explain what a carry is, and then I'll step into the program. Let's take two hexadecimal numbers, which is called as FF and FE. So these are the two hexadecimal numbers. An 8-bit highest hexadecimal number is FF, and the next before number is FE. So I can write this FF in terms of binary format, which is 1111 1111. So F is equal to 15. So it is in the form of 8421 code, 8421, again 8421. So 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. So 1111, Again here F is 1111 and E is 1110. So when I add these two numbers, I get 1 plus 0, 1, 1 plus 1, 10. Again you have a carry. 1 plus 1, 10, 10 plus 1, 11. Again here you have a carry. 11, 11, 11, 11, 11. So finally you have a carry. So the answer, if you see, again the answer is also an 8-bit number. Here you have 4 bits, here you have 4 bits. So this is again F, and this is 8 plus 4, 12, 12 plus 1, 13, which is nothing but D. So the answer is FD. When you add FF and FE, you get an answer is FD. And carry, there's a carry here, carry generated when you add it. So carry is 0. So it's a hexadecimal number, so I mention is FD and 0, 1. So this part we can continue to write a program by adding FF and FE in 8085 using assembly language. That is, by using the instructions of 8085 we can write a program. So let's start the program. Hope you're clear with the calculations. So let's start the program. So when you write a program, it is very important. You're going to take two datas. And the data, one is FF, other one is FE. FFH and FH. So for that, now I'm going to take a program. Let me use immediate addressing mode itself. So when I use immediate addressing mode, it is very simple for you to write the program. Let me say that MVI A, FF. So the first data I'm taking FF. The meaning is you're moving the content FF to the register or accumulator. So A is called accumulator. So FF is present in A. What is the next data I have? The next data is MVI B, FE. The next data I am storing in register B. So we have so many registers in 8085. So we have used two register A and B here. A is called accumulator and B is called B register. Now since we are writing a program for addition, so I give add B. So add B means the content of B is added with accumulator. That is FE is added with FF. Now after adding B, it will check for the carry flag always. So we use an instruction called whether carry is present or not. Jump on no carry. So if there is no carry, but in our addition we got a carry, we saw that in the calculation. First let's check for whether the addition gives a carry. If there is no carry, I introduce a loop L1. I say that L1 is, if there is no carry, store the accumulator result in some location 8200. So accumulator is a register. We saw in the beginning itself. Accumulator is a register which has got FF. In 8085, accumulator will only store the end result. It means after accumulator is added with B register, the result will be stored in accumulator only. So now this result is stored in 8200. This is what the meaning. So the accumulator result, what we got in the instruction, like we got adding FF plus FE, we got the result as FD. So this is accumulator result. Now accumulator result. So if there is no carry, the result will be stored in 8200. So once you go and say 8200, you can finally see the result of FD. But now we know that there is a carry generated in our calculation. So FD, there is a carry generated. So what do? We initialize a carry register. Initialize a carry register. That means C is a register which is pointing to a value 00. So first we took both the data, we added. After adding, we check for carry. If there is no carry, it can go to the result storage. But here there is a carry. So what we do? We increment the carry here. After, if there is no carry stored the result, go to L1. If there is a carry, increment the carry register. So what is the carry register here? 00. So now C becomes 01 because you have increased. Plus 1. That is your increment. After that, you store the accumulator content in 8200. Now we have to see our carry also. What do we do? Now the accumulator is free. So we write move C to A. That is, move the carry register to accumulator. That means carry content is moved to accumulator. That is your A register. Now accumulator has got carry. So we have to see that result. So what do? Store the accumulator content. Accumulator has got carry. Move to location. Why we move to memory addresses? We want to see that result as a layman, as a programmer. So we just move it to location. Then only we can see the result. Store the accumulator content in 8201. So 8201 is having the carry. So carry will be 01. So we have stored the result here. We have stored the carry here. So we can halt it. So this is the addition program of 8085. So this is how the addition is being performed in 8085. 8-bit addition. Thank you all.